Hello dear students, today we're going to talk about oscillation and simple harmonic motion. First, we'll have to know what are oscillations. Oscillations are nothing but the to and fro motion of a body about a fixed point. Or we can also say that any motion that repeats itself in equal intervals of time. Say we have many examples of oscillation out there, like the earth revolves around the sun, the mass attached to a pendulum, the mass attached to a spring. So here today we're going to talk about the mass attached to a spring. So how can we say that it oscillates about to and fro about a fixed point? Here we suppose a mass m which is lying there and has no motion. Okay, so what we will do, we will just apply a force and stretch this spring up to the right at point A. So now what will happen? It will start motion when we release the force. When we release the force, it will start motion. The mass will come back to the main position because the spring will compress. The spring will start restoring itself. The mass will come back to its position O. Now, what will happen when mass reaches the point O? It will not stop. Although it is the mean position, it is the right position of the mass, but it will not stop. Why? Because it has inertia. Because of inertia, it will continue to travel along the string. And at point A prime, it will stop moving. But what happens when it stops moving? It will not just remain there forever. It will start moving towards its main position. Why? Because the spring will start to release itself. It will start to come back to its original position. Okay, so here we will see that when the mass is at A prime, it has the most potential energy stored in the spring. It is stored in the form of elastic potential energy. But what happens when the mass comes through the point, the main point? Right there, it has no potential energy. It has only motion. So it has the kinetic energy. After reaching this point, due to inertia, the mass again goes back to point A. And at point A, the potential energy is again the maximum. So it just vibrates to and fro about its mean position, which is O. Now, we're gonna find out the equation for the acceleration of the mass. Okay, so here we will derive it from Hooke's law. From Hooke's law, we know that F is directly proportional to x. But what happens when we don't want this proportionality sign and we want to just find out what equality is, the force? So F would give out a constant, some constant. In this case we call it K, and x itself. So what exactly is K? This K is the constant of proportionality, which is called the spring constant. It is unique for every material. Okay, so for a spring made of steel, the K would be different. A spring made of brass, the K would be different, but it is always constant for same material. Okay, so now this one was when we have stretched the string. Okay, the K and the x and the force are in the same direction. Okay, but what happens when this mass starts to go back to this negative x, the A prime? What will be the equation then? Let's say this is the equation A. Then what will be the equation at point A prime? It would be F equals to minus kx. It's that simple. Where did this negative sign come from? we know that a negative sign, a force cannot be negative. So the negative sign here just determines that the force will be against the direction of the displacement. Okay, the force is applied here, but the direction of motion would be the other one. That's why we've put the negative sign here. Now what will we do? We will call this equation B. Alright, let's just move to the next page. Okay, so now from Newton's second law, which is F equals to ma, I think everybody knows that, so we call this as equation C. So now what we're gonna do, we're just gonna compare the equation, comparing the equation A and C. What would happen? In both equations we've given that the force is at one side and here it's also on the other side, so we can just compare it and get kx equals to ma. But what are we interested in? We are interested in the variables, the a and the x. Rest of the things, the mass and the constant k, are just constant. We have nothing to do with them. So we will just derive an equation for the acceleration. Okay, so it becomes k over m into x. This is the equation we want, but these terms are there, we don't want it, they're unnecessary. So what we're gonna do, we're gonna replace this whole thing with a proportionality sign. A is directly proportional to x. This is the case when we just pull the mass outward. Okay, but what happens when the spring is compressed? We will do nothing but we will compare equation B and C. In that case we will get an equation A is directly proportional to negative x. It's just the difference of signs. Okay, so now from this equation, this is the most important equation in simple harmonic motion. Okay, what we're gonna derive is that simple harmonic motion is a type of vibratory motion in which the acceleration is directly proportional to the displacement from the equilibrium position and always directed towards the equilibrium position. So see, we've got here, we've got the acceleration which increases with the x and which decreases with the x, which increases with the displacement and which decreases with the displacement. Okay, so this was all we need to know about the simple harmonic motion. You get it? Okay, so now we're gonna just discuss some other terminologies which are used in simple harmonic motion. We're just gonna speed up now. So first we're gonna discuss time period. Time period is given by t equals to 2 pi m over k. And what exactly is the time period? The time period is the time taken for one complete vibration, the time in which the spring completes its whole vibration. Okay, so this is what time period is. Now what is frequency? You will get the definition from the book, no need to just write everything down there. What is frequency? Frequency is the inverse of time. Simply, frequency is 1 over t. Okay, so what would we get? Frequency would be equal to 1 over 2 pi under the root k over m. Okay, and we're saying frequency is the number of vibrations executed by an oscillating body in 1 second. So it's just the inverse of time period and nothing else. Okay, and what about vibration? We've talked a lot about vibration. Vibration is the complete round trip of a body. Vibration is nothing but the complete vibration of a body about its mean position. Okay, and displacement is the instantaneous distance from the mean point. Amplitude similarly is the maximum displacement of the body from its mean position. We will use these terminologies while studying the chapter. Okay, so you have to make sure you study it yourself and watch the video I'm gonna give you, and then attempt the numericals I will give you and submit it tomorrow. Okay, thank you so much.